Hey guys, Doozer shop, minor shop update. I haven't posted a video in a while. Thought I'd just take you around and show you what I've been working on, just to let you know I'm still alive. So here we go. Alright guys, you're not seeing double. I've got two Kurt 6/88s. That's 6-inch wide, 8 7/8 opening. Let me kind of go around front. The one on the left I bought 20 years ago. I ordered it from Enco when Enco was still around for $400 and free shipping. The one on the right I found on eBay. I paid $350 and $100 shipping, so $450. The reason I bought the one on the right is because it's a perfect mate to the one on the left. I think some bubble wrap was on it. I could probably lay some phosphoric acid soaked in a paper towel on there. I wire brushed this thing, stoned it. Believe it or not, from storage, this one was pretty rusty, that I've had in my possession for 20 years. But these are pristine. I mean, I know you can't see, but no pock marks in the bed, nothing. And the serial number on the one that I've had for 20 years is 38,000 and change, and this is 44,000 and change. They're well up and past the 100,000 serial number mark. But this one that I bought off eBay here, used, it is virtually unused. And that's why I jumped on it, and luck would have it when I received it, I do believe it was maybe only bolted down once. I had some plastic, some blue plastic. I think it's that machinable wax in the jaws. Maybe it came from a trade school or something. But I've got two of them, and the reason I wanted two identical vices is because I used to have two on my Bridgeport mill at the place I used to work, and that was handy as can be. Having dual vices, trammed with the back jaws in the same plane, and of course the heights matched in the bed. So that's cool. That's what I wanted to show you guys. Is even though it was a little bit of money, it was worth it to me to have two identical, now a mate to the first one I had, vices. So I don't know if I'm going to put that on my Bridgeport over there, or the Gorton, which I've got the LW Chuck vise on right now. But anyways, yeah, I just wanted to share that. And just a quick rear shot of these Kurt 6/88s sitting next to each other after I got them all cleaned up and oiled. The mighty Pratt & Whitney, what did I do? Oh boy. So, I had a little project. I was facing a sprocket, chain sprocket, with one built up tooth, so I was taking the interrupted cut. And I noticed when I was taking the interrupted cut, the cross slide would shimmy in and out on me. And I put the indicator on the cross slide, and it was jumping in and out, 30 thousandths. I thought something's up. So I checked the Colchester, the mighty Colchester 17, and I put the indicator on the cross slide, and I was able to tug back on it, and I was getting maybe 2/10. And when I had the tool post and top slide on this, I could put the indicator right there and tug back on it. I know, unscientific as it may seem, but I can pull about 40 pounds maybe, tug back on it by hand, and I was getting 5 thousandths. I was getting 5 thousandths by hand tugging on the tool post here, and I was getting absolutely almost zero on the mighty 17-inch Colchester with the dial indicator pulling on the cross slide there. So that's how it goes. I took the screw out to see what was going on. And see, the thing is, it's fastened at the back because it's a ball bearing taper attachment. So I want to show you, hard to see. Let me kind of zoom you in maybe. See, because this casting here, it's got the hole for the feed screw, is closed up. This is not open in the back. The cross slide cannot go back. I might as well show you. But so far, right? So the scraping is pristine and unworn in the back because it could never get back there. It's a little rusty. But you can see, you know, the marks from the scraper. And as I pan forward, they get less and less and less. They pretty much disappear, right? They pretty much disappear. And actually, if I come and look at the front, you see a little grooves, and there's like a little bit of a gouge at the very, very front, right? But I'm not too concerned about that. And it's on both sides. A little bit of grooviness. But I'll tell you why. The underneath, the angle part of the dovetail, let me kneel down, right? But that's in really good shape. I know my focus probably isn't doing it justice, but the underside of the dovetail is in really good condition. So what I'm saying is, I might eventually take the whole apron off one of these days. Take the whole apron off and recut this on the Rockford open side planer. Because you take these slotty screws off and take them slotty screws off, this whole thing comes off. But what that meant is I was out of travel adjustment on my my tapered gib. So come around back here, and I got the bolts and the screws off. Oh, I don't know if I can show you. Probably not. Yeah. The screw adjusts the gib in and out. Let me kneel down, get a better purchase there. You can see the gib. Someone's got a roll pin in the gib. I think they made an extension or something at one point. But you can maybe see, can you see right there? I'm going to try and zoom in. Oops. All right. At a little bit of an angle, right in the center of the shot, there is a shim to the right of the screw. There's a shim between the gib and the cross slide. And that shim, if I can see it, is a piece of banding strapping material. I think it's like 12.5, 13 thousandths I ground. So in order to get my adjustment back, there's a shim on the back side of the gib, and it's trapped in between. There's another, this is a tightening screw, and then there's a loosening screw on the front. So that's what you do, is you put a piece of shim in there. And that's how that works. So even though I'm worn on the flat, like I say, the angled part of the dovetails is in really good condition. And if you can't see and it's not in focus, you may have to trust me on that. But eventually, I'm going to replane the flat part of the waist. Maybe you can see the outline of the dust on the magnet over here on the surface grinder where I was grinding that shim for the Pratt & Whitney, the gib. Used a piece of banding, strapping, what have you. And I think they're about 25 thousandths. And I ground it down about 10 thousandths. So I got about a 14, 15 thou shim, something like that. But boy, oh boy, this little surface grinder is as handy as a shirt pocket. Even though I got the big Okamoto, I don't think I could ever get rid of this one just because it's so nice to use. So the taper attachment. So this thing has, it's got the ball bearings in it on the sides. Let me pick it up. That's all it is. It's a sled with adjustable, eccentrically adjustable ball bearings, right? And it just rides in the slot. This trough here. Come on, fit down. So that's the taper attachment. And we stand back, you can see the taper attachment. It slides in there, and you set the offset with this adjustment here. It's a rack and pinion. So that's all good and fine. So what this is called is a telescoping taper attachment. On the mighty Colchester 17, you take that nut off to release it. The telescoping taper attachment on the Colchester, when you're not using it, there's a nut there that holds the screw with the bearings of the crank handle in the front. This Pratt & Whitney does not. I got the crank off. It attaches in the back and gets immobilized when you're not using the taper attachment. The lead screw has bearings, and it gets fastened hard fast with the carriage in the rear. And there was some sponginess there. I've got the cross slide nut is a post that goes in here, and there's two screws which adjust the backlash. I got that out just to clean it and kind of take up. There's a little bit of play a few places. So let's go over to the other bench and I'll show you what I had going on. And by the way, just so you don't think I'd misplaced it, there's the cross slide crank. It just comes off, and it's splined inside there. It's got the spline for the telescoping feature. And here's the half nut, not the half nut, here is the cross slide nut. You can see it set screws to the side of that post. There's a flat where the set screw bears. It's almost too low. Might be nice if that was a whistle notch instead of just a regular flat. This thing is in fine condition. It's like brand new. Let me see. I don't know if I can get the good. It's hard to shoot. But it's in fine condition. what the deal is on this side, here, let me show you. So that's, now this is a steel part of the nut. It's kind of filthy, I gotta clean it. And it's 18 threads per inch worm. So that goes on there, and you take up the backlash, and the 5/16 18 screws come in there from the top, right? So you loosen one and tighten the other, and then you can set the backlash. And it's neat they made this part of the nut out of steel because it's less than half the width of the bronze. So they want to make it out of something more durable, so I guess the whole thing wears an even amount. And I don't know what those pins are for. There's a pin there, and a pin there. Might be some kind of hole for lubrication, maybe? I don't know where the lubricant goes. I'll have to see. I don't know where the lubricant goes. Maybe it's not a connection point for lubricant. I'll have to see. We'll figure it out though. I'm gonna clean that really good with a nylon brush. I got all kinds of brushes. But had ball keepers. It had linear ball ways. Oh, here's the screw, and here's the bearings. I'll come back to that in a second. So this piece bolts to the rear of the carriage. This is the shot pin to lock out the taper attachment. You lock that in and it immobilizes the slide. Normally the slide, which is that thing connects in the middle there to the taper attachment. And you can see it's got V-ways, this V and that V, and here's the other V-ways, right? And a whole bunch of balls. You got balls, 5/16 balls go in here, and I had to make a new triangular felt wiper on both of them. So, as I said, you know, this thing, it's supposed to have 12 balls per side, 12 there and 12 there. There was only 3 balls on each side. So instead of 24, you had 6. You know, you're missing 4 times as many. So these bolt, I think these bolted like this. It's bolted like that. That goes in the middle in here. The balls get loaded, and this is the bearing retainer. Someone's been in there, dude. Look at the chowdery chisel marks. But I mean, I've got the right tool for the job. I mean, this is, you're supposed to use a spanner wrench, pin spanner wrench for these, and this fits dandy. I guess the whoever had this didn't own one, so they made do with whatever they thought they could do. I think that's how it goes, and then that one goes like that. So that's cool. That slides in, and this pin nests into, not that side. Yep, dropping stuff. nests into there. That's like a hardened bushing with a taper in there. But if there's any kind of looseness between there and there, that connection, right? That's got to be tight. I mean, that thing has to have no play. You see it split. The split bolt is out of it currently. But you got to tighten that up, and it's got to seat in there. And this, I think, is cause of some loosey-goosiness and some spring action, right? So that's how that works. So this joker slides in there. Let's get kind of like... This goes in there, the balls go in, the lead screw with the bearings goes in there. So this is what I was talking about, right? Let me get you focused down on this. So this goes in the crank handle. You can see there's some fretting corrosion in the crank handle area. See, now that's just got a center hole in there. On the Colchester, I think that's a male thread and a nut goes on there. So that's how it immobilizes it. On the Colchester 17, the thrust of the lead screw, or the feed screw I should say, is taken up right in the front when the taper attachment is not in use. This Pratt & Whitney, these bearings get fastened in this housing, and then that pin gets put into, well, I showed you the hole, gets put in that hole to immobilize it. So your Acme nut goes in the Acme thread, these bearings go in that housing. This housing would normally slide on these linear ball rails, which was missing balls. But when it's locked out and you're not using the taper attachment, that pin immobilizes it, because that pin gets inserted into the side of this casting, and this pin is part of this housing, which is bolted and pinned fast to the carriage. So that's how it's immobilized. So there's a lot of room for this thing to have play, right? It can have so much play, whereas the Colchester 17, all the play is eliminated by one nut on the front. This thing, instead of the nut on the front to go right into the bearings where the hand crank is and the dial is, this thing goes through bearings in a block on rails with a pin, or a socket and a pin, and this pin slides in this block, which gets tightened to here, which is tightened to this, which is bolted to the... It's just a lot of baloney. Whereas the Colchester just does it a lot more simple. And another thing I found, see, these are ball bearings. They are angular contact ball bearings. So that means they're loose until you load them on the end. These could be thrust bearings, but Pratt & Whitney chose to use angular contact ball bearings because these take the thrust, 100% thrust. There's no radial loads, only axial loads along the axis of the screw, nothing radial. But these have to be preloaded in order to have a stiff axial preload. But I think all the preload was gone because the races have to touch and have some, how can I say this? The races have to touch, and there either is some preload built in or there are some shims that create a difference between the inner and outer races in the axis plane. So these, I don't think these had any preload left. So this is a bearing nut and you need a hook spanner, and I took that off. It was tight as a crazy person. It was tight. But I put a spacer washer in between these two to create a gap so I could pinch these and create some axial preload. I think it was one of these washers here. I found it fit the shaft. It was a 11/16 shaft. So I found one of these washers. It's like 15 thousandths thick. So now I'll tighten this bearing collar nut, and then I can get all the preload I want. And that preload, instead of tightening up this adjustment nut, I guess you'd say, and just putting the maximum preload on the bearings set by the races, the preload on this now, when I tighten this fully, because the washer's in there, the preload is no longer governed by the bearings. It's governed by how tight I make this adjustment nut. Before, this would be fully tight, and as tight as you made that, the only adjustment of bearing preload was how the races were ground and set by the race faces themselves. But now that I put the washer in there and spaced the races apart by 15 thousandths, my crush and preload on the axial direction comes from how tight I tighten this. Before, it wouldn't matter how tight I tighten this. I could tighten this, 100 foot-pounds, and it wouldn't give the bearings any more load. Now, the preload that the bearings receive is governed by this, whereas before it was hard governed by how the races were ground. So this thing, I can over-tighten this now. Before, I could not over-tighten it because it was, like I said, set by the bearing race spacing. Now I'm going to have to be careful. I'm going to snug this up tight but not kill the bearings. So a friend of mine, Jim, I was talking to on the phone, he says, I was going to probably put blue Loctite on it or something. I got all kinds of Loctite up the yang here, in my little Loctite container. He says, can you put like a 1/4 28 set screw on the threads with a piece of lead or a piece of brass? And there's a nice thick section. Maybe right in here. Maybe I can get a from the side a 1032 or something, or a 1024 in this kind of beefy section here. Maybe this is more beefy, with a lead or a brass tip. So anyhow, so that's cool. That's what's going on there. So instead of 6 balls, I got the full complement of 24. Instead of bearings with basically 0 preload, I've now got adjustable preload with as much preload as I want. So, oops, that's fine. That's fine. I wanted to pick this up to show you guys. So, through this window, you engage the taper attachment. So this guy, if I wanted to immobilize, if I found that this was a source of play, I could put a plate across here. There's even, I could put a plate across here and a plate across, well, there's nothing here. That's not to say, I could put this in the mill. And is this a thick section? Yeah. This is a very thick section right there. I could put like a 1/2-13 thread in there and a plate across with a 1/2-13 thread in the middle, and put in one 1/2-13 or 1/2-20 for that matter screw and get rid of this. So a nice solid, maybe 1/4 inch plate, 5/16 plate, 3/8 plate, whatever. Get rid of this. Just drill a 1/2 inch hole in the middle for the screw and a 1/2 inch hole. I'd face this and then drill and tap in there. If I needed some more rigidity, I'll have to test it with this, and the pinch bolt goes in there. So that was my thoughts on that. So a few sins here that could lead, the loose balls being missing, less preload on that, and also I don't really think that this nut was in there as tight as it could be. Even though it was set screwed in place on this post, I could drill and tap in the center of that, maybe 1/4 20 or 5/6 18, and put a nice big thick washer on top to keep it positively seated against the flat of that surface. So that's pretty cool. I might do that, don't know. Oops, that's just in there. So that's what I've been working on, trying to get this thing figured out. Got the cross slide down there. I'm going to try and get this back together sooner than later. I did take this all apart. I found one of these little restrictors that oils the ways clogged, so I got some MIG wire and I rotted it out, and I cleaned a whole bunch of schmoo that was all underneath here. So that's cool. I'm gonna put this back together, and I'm real happy I dug into it and gave it a good once over, and hopefully this will fix the problem of a little sponginess in the cross slide. So there's that project. My friend Mark was nice enough to donate to the shop, to the channel, this 1.5" boring bar, and I didn't have a holder for it. This is a CA tool post, one step bigger from the CXA. It's the CA tool post, and I did not have a boring bar holder for the 1.5" bar. So Mark, friend of the channel, gave me this bar, and I had to get a holder for it. So I got this for, probably paid too much, 80 bucks off eBay. I know Shars sell these for about 70, but oh well, it's a Dorian tool, it fits well. This one that I've had with the set, that's 1.25 inches and a bushing going down to 1 inch. So that's what I had previously, but now I've got a nice 1.5" one for my my bar. So that works. And still loving the quick tightening handle there. That thing's really sweet, and I covered that little project in a previous video. So yeah, still loving it to pieces.